Next, let us talk about the moment resistance. When we talk about the moment resistance, we are referring to the ultimate limit states. For the design of ultimate limit states, the calculations of the design moment will be on the basis of the factor of safety, 1.35 for GK and 1.5 for QK. A member subjected to moment will undergo bending, and when a member is undergoing bending, the internal stress distributed. This leads to the tension regions and the compression regions within the member. The concrete is good in compressions but poor in tension. You will need reinforcement bar to strengthen the concrete in resisting the tensile stress developed in the member. Therefore, when we talk about the moment resistance of a member, it is often associated to the process of determining the amount of reinforcement bar required in resisting the moment acting onto the member. You can say that the moment resistance is associated to the areas of reinforcement bar. You design for the moment resistance. That means you are designing the amount of reinforcement bar required in the member. We have structural elements, beam, slab, and staircase. These members can be subjected to moment, and therefore you will need to design the reinforcement bar to be embedded inside those structural elements so that it will not fail under the design moment. Now, in the design of the moment resistance, a member can be singly reinforced or doubly reinforced. These are the equations for the design of singly reinforced as listed in the summary table here. And these are the equations associated to the doubly reinforced member, and it is summarized here. The main difference between the singly and doubly reinforced member is that the existence of the compression steel bar. For the design of a singly reinforced members, you only need to determine the tension steel bar area. Whereas for the doubly reinforced member, you need to determine both the compression steel bar and the tension steel bar. Why they are different? In the singly reinforced members, the concrete strength is sufficient to carry the compressive stress when the member is subjected to bending. When the compressive stress exceeded the capacity of the concrete, you require compression steel bar to strengthen the concrete, resisting the compressive stress, so that the members does not fail in compression. In another word, theoretically the doubly reinforced member is stronger than the singly reinforced member, although the cross-sectional area of the member is the same. You can interpret it in this way. In terms of the cross-sectional areas relative to the loops acting onto the member. When the cross-sectional area of a member as compared to the loops acting onto it is relatively larger, then the member will be singly reinforced. And when the cross-sectional area is relatively small as compared to the loops acting onto it, then you require strengthening of the compression steel bar, and therefore doubly reinforced member is required. This principle shall differentiate the applications of the equations for the singly and doubly reinforced member among the beams, slabs, and staircase. What you see in the summary table here, the equations for singly reinforced members is applicable to the beam, slab, and the staircase universally, which you can notice from the example revisions questions given for the beam as demonstrated here, for the slabs, and for the staircase. As long as the member is subjected to moment, the same set of equations shall be used. Now, if you look at the doubly reinforced equations, you see the applications of those equations are more strongly correlated to the design of beam. Their applications in the slab and the staircase are relatively not likely. Why is it so? The main reason it would be due to the effective cross-sectional areas of that particular member. When we talk about the beam, these sections are relatively small. However, the loops acting onto the beam will be relatively large. When this happens, you may need compression steel bar so that the members is doubly reinforced. However, when you deal with the slab and the staircase, both are relatively large structural elements. Their width can easily exceed 1 meter wide. Because of that, normally the slab and the staircase are designed in the similar manner, which is on the basis of 1 meter unit width. Because of the large structural element, there are plenty of compression areas within the cross-sectional areas. The compression resistance of the members is normally more than enough to cater for the compression stress generated due to the bending moment acting onto the member, and therefore you do not require further strengthening of the concrete with the compression steel bar. Now you see the applications in terms of the design of the moment for the beam, slab, and the staircase. The chances of the slab and the staircase are relatively low for them to be doubly reinforced member. This doesn't mean that there won't be a doubly reinforced member in any chance. It is still possible, which normally occur when relatively thin members is provided, or when the members is subjected to relatively large bending moment. However, based on my personal experience, under normal circumstances, you will expect the slab and the staircase are singly reinforced.